So let us start our journey of entering into a beautiful topic of functional groups. Functional groups. An atom or a group of atoms which have the ability of changing the chemical properties of a carbon compound attached to a particular chain or a ring or an aromatic system are known as functional group, students. We have already read a ton of functional groups, like we've already done 17 of them. But what is the exact functional groups that you need to take care of in your study, which will lead you to a very good rank in JEE Mains and JEE Advanced, right, students? So let us go and discuss those. Very first, hydrocarbons. Hydrocarbons, the compounds of carbon and hydrogen, right? It's a study of that. We'll go to the next one, which appear in your class 12th syllabus, haloalkanes and haloarenes, right, students? The compounds which have halogens belonging to which group? Yes, what have I heard? Which group? Group 17, ma'am. Yes. Fluorine, chlorine, bromine, and iodine. These atoms, when attached to a particular carbon chain or any particular carbon system, they change the properties and hence they are called haloalkanes and haloarenes. We will study the properties of that. Third is your, what is it? Alcohols, phenols, and ethers. I generally hear things like, ma'am, this is the longest chapter. So many named reactions are there. We don't know how to do it. But don't you worry at all. I'm going to cover every single topic, every single doubt, every single logical question here. We are going to cover it here at IITianGuide, so stay with us. Next, you have carbonyl compounds. Carbonyl compounds along with alcohol, phenols, and ethers. They cover the maximum weightage in your JEE Mains and JEE Advanced. Of course, all of these functional groups, the base still remains beta, GOC. You have to study general organic chemistry in order to reach to the study of these compounds and do well. All right, let us now see what we study here. We study, obviously, ma'am, aldehyde ketones. Ma'am, this much we know, ma'am. This much, you know. I know, beta, you are very intelligent. Carboxylic acids. Array, ma'am, we knew this. We knew this. I know, beta. No problem. Amides and oil halides. Right? Ma'am, we know this. We are going to study the reactions, the name reactions, all of these here. All right. Fifth is amines, the nitrogen containing compounds. Primary, secondary, and tertiary amines. What are they? How are they related to each other? They are related as functional group isomers, right? Let's now go to the application of all this. We study in biomolecules. Who is corn? Corn? Ma'am, who is corn? Corn is this, CHON. Without these elements, there is no life possible on the face of this earth. So, corn hai ye? Corn hai ye. All right, students. So, these are the various things which we will be studying. And I want to tell you the basics and the most important things to study for these chapters in order for you to get the best rank possible in JEE Mains and JEE Advanced. So students, stay right here with us and let me tell you how to cover this with an edge. All right then. Let's go to basic order of study. Why do students find organic chemistry or the study of functional groups so tough? Ma'am, there are so many reactions. Ma'am, please, ma'am, too many reactions. We are not able to even remember the reagents. It's endless. I know, beta, it is endless. I know. But you don't have to study all the endless things. You have to zero down to some very basic reactions. You have to understand the types of reactions and you're good to go. The reagents, yes, definitely you have to make sure that you learn them. Definitely. There are some core topics in organic chemistry. Once you master all of them, right, then any question which will appear in front of you, you'll be able to decipher how to solve that question. And that is what IIT is looking for. IIT is looking for those brainy minds which can go to the depth of the question, find the logical reasoning and tick the right answer. So stay right here with us. We are going to cover all of that. Let us tell you the chronological order of the study of functional groups. First thing that you come across for study of any organic compound is the nomenclature, beta. How to name a compound. Until unless you know how to name a compound, you will not be able to, study that compound. So not just that, in organic chemistry, you would have seen besides the IUPAC names, there are common names which are associated with a certain compound. We must know that also, correct? Second is isomerism. Isomerism must be studied in order to study the different forms taken by one single compound, right? Whether it is structural or stereoisomers. Yes, ma'am. We know that stereoisomerism is very important. Yes, beta, it is. Stereoisomerism of certain compounds is very important, just like haloalkanes, right? And hydrocarbons. You have to understand the EZ isomerism, the cis-trans isomerism, and the optical isomerism, beta. That's very important. Very, very important. You have to learn. You have to understand the difference between chiral compound or chiral carbon, I should say, and optical activity. Very important, beta. Very, very important, right? And conformational analysis, beta. Do not forget, every year in JEE Advanced, conformational analysis has one question. It is very important. Very important. You must study it, especially cyclohexanes, right? Then you have MOP. What is MOP? Methods of preparation. What methods of preparation? You need to know how one method of preparation becomes the chemical property of the other functional group. So isn't that one step more easier? Haven't I made it easy for you? Let us go to the fourth one, properties. Properties, you have physical properties and you have chemical properties. In physical properties, beta, it is very simple. First, you should understand the state of existence of that particular compound. Second, you should, whether it's a liquid, solid, gas, lower members are mostly gaseous and liquids, higher members are liquids and solids for a number of functional groups. So you can generalize, right? Whether it is aromatic or it is aliphatic or alicyclic, right? You have to understand that, because that will give you a difference in the flame test. Then you have to talk about the solubility. Solubility is, beta, directly related to what? Your mu, which is your dipole moment Q into D. You have to understand. Now, fourth one, what we are looking for is melting point and boiling point. But a lot of compounds have this special characteristic of high melting point and low boiling point. Cis-trans isomers, right? You have to study that melting point and boiling point of compounds. These questions do appear in the exam. All right. Then you have melting point and boiling point. Straight away, you study these few properties, right? Solubility also you have to study in acid, base, and in water. And water, does a functional group show hydrogen bonding? If it shows, then yes, it will have effect on melting point and boiling point also. Correct, beta? So these are the physical properties that you must talk about. Also, with this, one thing more is related, that is your flame test. Sooty or non-sooty flame, you must understand. It is useful in deciphering certain, word problems. Yes, that are there to identify a certain compound. Then you have chemical properties. This MOP and chemical properties go hand in hand. Why, beta? Because once chemical properties may be methods of preparation of the other functional group. I hope you are understanding the linkage of one topic to the other. Then fifth is uses. I will advise all of you listening to me right now on this platform that please, for uses, you have to consult your NCERT book in that, or your state board book, right? More or less, they are the same, right? So all of the syllabus is based on that. And the uses you have to cover from there. As such a particular compound, there are so many compounds under a particular umbrella term of a functional group. But specific uses have been mentioned in the books like NCERT. Please stick to them, right? All right. So let's go to methods of preparation and chemical properties. Right. Now, beta, if you look at the method of preparation of an alcohol, right, I will just talk about something like this. Then you have aqueous, KOH, right? You will have RCH2OH. This is just not the preparation of an alcohol, right? Right? This is, but it is also the chemical property of a haloalkane. Correct, beta? So they go hand in hand, right? So you are supposed to particularly follow that particular chronological order in order to study. Also, the next thing which is very important in studying these two topics is that you have to study one thing, which is types of reactions. Once you identify types of reactions in chemistry, right, in especially organic, when you study, when you relate different reactions in different categories, you can actually zero down all methods of preparation and all chemical properties very subtly, and it will be covered like a pro. First is addition reactions. Second is elimination reactions. Right? In elimination, ma'am, what are the reaction types? You have to tell us. Yes, yes, yes. I will tell you. They are dehydration reactions. This is loss of water. Loss of what? Loss of water. Right? You remember, we suddenly say I'm dehydrated. Dehydrated means loss of water. Same, dehydration is elimination of water. Then there is D. D means loss. Decarboxylation. Decarboxylation, which is loss of CO2. Then D, yes, ma'am, I know everybody is thinking, ma'am, dehydrogenation. Yes, 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 right? Loss of hydrogen. Dehydrohalogenation. Dehydrohalogenation. Yes, ma'am, we know one halogen is involved. Very good. Loss of X. And dehalogenation. Dehalogenation. Right. Let's go to dehalogenation. So dehalogenation is loss of halogen molecule. All right. So these are the various reactions of elimination that you will be encountering in every single chapter. All right. Third is your substitution reactions. And fourth is your rearrangement. Fry's rearrangement, you know, right? All right. So you know these type of reactions, right? The rearrangement type of reactions, right? So redox is a part of all these types of reactions, right? Redox is not any particular, does not belong to any particular category. It's a part of all this, right, students? So once you have, included every single named reaction or any other reaction in this particular 4 categories, you will be good to go, beta. You will be good to go, right? Let us go to study of hydrocarbons. Methods of preparation. You do your Woods reaction. That is a substitution reaction. You go to Woods fatigue. You go to fatigue, right? That is, and then you go to your Ullmann reaction, your Corehouse synthesis, right? All these 5 reactions, all substitution type of reactions. And Corehouse synthesis, it's a reaction which can give you unsymmetrical alkanes also. Then you have reduction of alkenes and alkynes, right? That will give you alkanes, right? Then methods of preparation. Let me just note it down for you. First of all, you have Woods fatigue. Then you have fatigue. Then you have Ullmann. And then you have Corehouse synthesis, right? All right. Then you have your reduction methods. These are all your substitution methods, right? All right. Then you have your reduction methods. Then you have your elimination methods, right? That is using NaOH and CaO. This is your decarboxylation method from acids minus CO2. Then you have your coal-based electrolysis. Coal-based electrolysis, right? Right. This is how you understand the MOP of alkanes. General formula, ma'am, we know that HN, H2N, CnH2n plus 2, right? You have these methods. You have tons of other methods also. Yes, some students we are definitely going to say, ma'am, Clemenson's and Wolff-Kishner is also, yes, definitely, they are methods of synthesis, right? You have red phosphorus, yes, not a problem. That HI and red phosphorus, that also you can do. Yes, they are, right? So as and when you focus more into the study of functional groups, you will realize that there are many chemical properties which could have become the methods of preparation of that. This is what helps you in carrying out a ton of conversions, all right, which are a core part of the questions which are formed. So direct questions, obviously, will not come. They'll not give you a simple reagent. Rather, the application of those things, like if I go back to the previous slides, right, they can give you any such elimination method, and then they'll tell you how to, they'll ask you a question according to that, right? Come on, guys, let's go to coal-based. Then let's move ahead from all these methods of synthesis. Let's go to your alkenes, bacha. Again, reduction reactions. Reduction is basically addition, right? Addition reaction, addition of H2, right? This is also addition. So can you see addition, elimination, and substitution reactions for alkanes? First is reduction, which is addition of hydrogen for your alkenes. The other methods are basically, obviously, reduction of alkynes. So Birch reduction, right? Then you have your Lindlar's catalyst, very important. Lindlar's catalyst has to be poisoned. Anything you want to poison, you put liquid sulfur or barium sulfate beta, right? Or quinoline, they act as poisons to Lindlar's catalyst. Then you have Birch reduction also, right? All right. So the second one, yes, what do I hear? What else is the method of preparation of alkenes? Oh, yes, ma'am. We have elimination reactions. Yes. Elimination of what? What beta? Ma'am, you just taught us elimination of HX, dehydrohalogenation. Yes. And dehydration reactions where, yes, then dehalogenation reactions also beta. They can be used for the synthesis of alkenes, right? See, just we are covering two simple reactions, addition and elimination. And look at what you got. You got all the methods of synthesis of alkenes under two terms. So this is called making of mind maps, right? You all can make mind maps of your own like this. It's very simple, right? All right, let me go ahead. Right, let me go to alkynes. Hydration of carbides. Hydration reaction of carbides will give you methods of preparation of alkynes. All right, that is what you can do. And obviously, ma'am, yes, dehydrohalogenation. Dehydrohalogenation, right, of vicinal dihalides. You can carry out that to get, alkenes. Obviously, sodium in ammonia can function as such a reagent, and you can have alcoholic KOH. Yes, you can. Okay, see, in just a few minutes, you have all the methods of all the hydrocarbons fully covered right in front of you, right? So this is the magic of mind maps. This is the way you do certain, functional groups in just a matter of few minutes. You can cover, you can quickly revise the things, right? And you can give your preparation an edge, right, students? Let us go to the chemical properties. The chemical properties, ma'am, we get very confused here. No need to get confused, bacha. No need to get confused. So first is free radical substitution in alkanes. All right, free radical substitution in alkanes. Right. This is the first type of reaction you have. Correct, beta? Then what else is the chemical properties, right? After free radical, then you have aromatization. Then you have combustion. Combustion can be in free supply of air with a lot of oxygen. There can be controlled combustion also. Different products will be formed, right? There can be controlled combustion also. Controlled combustion, right? Okay. Then is your pyrolysis reaction, right? Then you can do that. You have pyrolysis reaction. If you have chemical properties of alkenes, now this is a very important topic, beta. This is a very important topic and many important reactions. First of all, which comes to my mind is your ozonolysis reaction, right? Ma'am, you did not, it's a combination, right? Pyrolysis is breakdown basically, right? Okay, free radical, this is a substitution type of reaction, right? So then you have ozonolysis. Then in alkenes, one beautiful, very beautiful type of reaction, a class of reactions which is very important in alkenes is electrophilic addition. Electrophilic addition reaction. Okay, whether it is the addition of a halogen, whether it is the addition of water, whether it is the addition of HX, Markovnikov's and anti-Markovnikov's rule. Right, beta? These are very famous, ma'am. Yes, we know them. Yes. Then you have addition of water. Then there are few more reactions over here. You have hydroboration, oxidation. You have oxymercuration, demercuration. You have such important reaction here. You have simply addition of water in the presence of H2SO4 also, beta. So two named reactions are coming here also. Addition of halogens, addition of HX. So I've had so many, I've told you addition of water also only has 3 subgroups, right? These are all coming under addition reactions. So very important, beta. You must take care. See how life has become easy when you start segregating the named reactions into groups. Correct, bache? Right? So let us now turn to your alkynes. Alkynes also, beta, they give electrophilic addition reactions. Electrophilic addition reactions. So you can have addition of, one second, beta. We have addition of hydrogen also here. Let's go ahead now. Electrophilic addition of hydrogen, water. You have one famous named reaction, Kucherov's reaction over here. You must do that, right? Which is 1% HgSO4, 40% concentrated H2SO4. This is known as Kucherov's reaction. You can add HX, you can add a molecule of halogen, right? All these are under addition reactions in case of your electrophilic addition. Then you have, I'd like to go back. Then there is combustion reaction is common for alkenes also. All right. Okay. Then you have, first was this, the next is basically you have combustion reactions also. Burning of, combustion is basically, it's the burning of a compound in free supply of air, free supply of oxygen. Okay, that is what is combustion reaction. So you have addition of water, H2, HX and X2, right? That is how you cover your, basically your alkanes, alkenes and alkynes, right? Then you have your very beautiful aromatic compounds, right? Aromatic compounds. What is aromatic? In the earlier days, the aromatic compounds used to refer to those particular compounds which have aroma in them. You can open your mom's spice box in the kitchen. You'll see so much of aroma is there. All of them have, mostly all of them have aromatic compounds. But the definition is not suitable for the chemist, right? We need to have more of chemistry angle. So planar, cyclic, right? Conjugated double bonds. What is conjugation? One after the other, double bonds are getting repeated, right? So conjugated double bonds and delocalized, not just conjugated double bonds, delocalized electron density is also very important. the electron density can shift. So delocalized electron density is very important. Ma'am, you forgot Huckel's rule. No, I have not forgotten. Then you have Huckel's rule. You have Huckel's rule. 4n plus 2 pi electrons. N's value is 0, 1, 2, 3, 4. Very famous example, ma'am, we know. Ma'am, we know. Yes, bache, you know it is benzene only. It is benzene. My super kids, you all know everything. You guys are very intelligent. I know benzene. Here the N is what? 4n plus 2 is equal to 6. N is 1, ma'am. We know it. Yes, correct. So this is your aromaticity, right? These are conditions for aromaticity. Then further, you must study your anti-aromatic and non-aromatic, bache. Non-aromatic. One of the very famous reactions, benzene and its compounds, their chemical reactions and their types. First is your electrophilic aromatic substitution. Ma'am, what did you say? Substitution? You just said in alkenes they undergo addition reaction. Yes, beta, I only said they undergo electrophilic addition. But benzene, due to its aromatic nature, beta, it is so stable that it does not undergo any reaction with bromine or KMnO4. No electrophilic addition, beta. No electrophilic addition. Benzene is too stable to undergo electrophilic addition. No, benzene will rather undergo electrophilic aromatic substitution. So in short, if I were to write down, benzene will react with these following electrophiles, right? This is called chloronium ion, right? This is called chloronium ion, or you have bromonium ion, right? The reaction with fluorine is very highly exothermic. There are different methods of synthesis for that. For iodination, the reaction is reversible. The reaction mechanism is different. There is a different type of reaction for that. But yes, we'll be studying that in haloalkanes and haloarenes also, right? Let us now go to your methyl carbocation, or let's say any alkyl carbocation. Then you have a psyllium ion, RCO+, right? Then you have SO3 as the electrophile that can react. Yes. So you have a ton of reactions, a ton of substitution reactions, right? So you have all of these under the beautiful category of electrophilic aromatic substitution. Now the mechanism of these is very important, right? This is in the presence of FeBr2. This is in the presence of AlCl3, right? This is HNO3 nitrating mixture and H2SO4, right? This is in the presence of, again, AlCl3 or FeBr2, right? This is in the presence of H2SO4, concentrated H2SO4 oleum, right? This is RCOX, right? You can have a ton of reactions, used for this, right? And you can have electrophilic aromatic substitution as one of the major chemical properties of benzene. So this is the major summarized portion for you for the chapter hydrocarbons, what you all need to do and what you all have to study under various conditions, under various type of reaction types. I have summarized everything for you. Make good mind maps with this and study in this particular manner to cover your chapter with the biggest edge and get important questions correct and get a good rank. Thank you.